From the expansion a plus b, the quantity raised to n, when we have n that is equal to 0, then this a plus b, the quantity raised to n, when n is 0, that is equal to 1. So it means to say when n is 0, this must be 1. Now to illustrate the expansion, when n is equal to 1, then we have numerical coefficient of 1 and 1 also, where that is a plus b itself. But when n is equal to 2, or the popular square of a binomial, then we have the numerical coefficients 1 for the first term, 2 for the second term, and 1 for the last term. And as you keep on increasing n here up to infinity, you will notice that you're just adding the numbers in between to form just like this. 1 plus 3 gives you 4, 3 plus 3 gives you 6, and 3 plus 1 gives you 4. You also notice that it is symmetrical. So if this is the middle numerical coefficient, then two sides are equal also. So in here, when n is equal to 5, two middle terms have the same numerical coefficient, that is 10 and 10, which came from 4 plus 6, 5 and 5 and 6 here. 20 is the middle coefficient, 15 and 15 on both sides, and 6 and 6 on the second term and the second to the last term. Now these are some of the properties that we can observe in the Pascal's triangle. But this is all about the expansion. Now let's talk about the expansion with the idea of combination and the binomial theorem. All came from the Pascal's triangle. In the binomial theorem, it says that for any positive integer n, from the expansion a plus b, the quantity raised to n is equal to the summation of the combination of n taken I at a time times a raised to n minus 1 times b raised to I, from I starts from 0 to n. So let's have a review of a combination. This is found in your calculator. Combination is expressed in two ways. C taken n as C. Okay, this is a k taken from n number of elements, and that can also be popularly expressed in this way. Combination of n taken k at a time is equal to n factorial over k factorial times n minus k quantity raised to quantity factorial. Okay, n here is the total number of elements, where k is just a subset or a part of the elements. So let's have letter A, 5 taken k, 5 is n, and k is 3. So 5 factorial divided by 3 factorial, 5 minus 3 factorial becomes 2 factorial. Okay, so 5 times 4 times 3 factorial, we can now cancel out 3 factorial here. So we have 5 times 4, and 2 factorial is simply equal to 2. So 2 times 1 is 2. So 5 times 4 divided by 2 is 10. Another 10 factorial, 10 taken 8 at a time is equal to 10 factorial divided by 8 factorial times 10 minus 8, the quantity factorial. So that will be 10 factorial is 10 times 9 times 8 factorial. So we can now cancel this. Divided by 2 factorial becomes 90 divided by 2 is 45. So this is just a simple recall of the combination rule, and you can find that in your calculator. Just find this in your calculator, and usually found on top of the division key. So how do we expand u plus v quantity raised to 7? So to do this, let me present to you the usual way. So some books may present the solution this way. And the first thing you need to do is to list down the first term u. So you start from the exponent 7. So u raised to 7. Now move to 6. U raised to 6. U raised to 5. U raised to 4. U raised to 3. u raised to 2, u raised to 1, and u raised to 0, you don't need to write, okay, because it is already 0, 1. Next, y, we start from v, so this will be v raised to 7, v raised to 6, v raised to 5, v raised to 4, v raised to 3, v raised to 2, v raised to 1, and v raised to 0 is simply 1. You also notice that when we add the exponent, 6 plus 1 gives us 7. That's one of the conditions. The sum of the exponents must be 7. 5 2 is 7, 4 3 7, 3 4 7, 2 plus 5, 1 plus 6, and then 7 are all 7. Okay, the next thing we need to do here is to determine the numerical coefficients of each term. This exponent 7 is the numerical coefficient of the second term. That's automatic. And by the rule, because it is symmetric, the second to the last term will also follow 7 as the numerical coefficients. The second, we're done on the second term, and the second to the last term will now move to the third term. To get the numerical coefficient of the third term, you multiply the numerical coefficient of the first term times 6 divided by 2. So we have 7 times 6 divided by 2 is equal to 21. So this must be 21. The third term numerical coefficient must be 21, and the third to the last term must also be 21. Now to get the numerical coefficient of the fourth and the fifth, then you just need to get the product of 21 and 5, and then you divide it by 3 because you're now on the third term. So that will give us 21 times 5 divided by 3, 3 and 21 divisible by 3. So this is 7. 7 times 5 is 35. It means to say the numerical coefficient of the fourth and the fifth term is 35. So this is 35, and then the fifth term is also 35 because they are symmetric. And the operation is addition. So the expansion is done. You can also check it out on the Pascal's triangle when n is equal to 7. So let's check. We can also check that when n is equal to 7, the numerical coefficients are 1, 7, 21, 35, 35, 21, 7, and 1. And it's symmetric. 7 and 7, both the same, 21, 21, 35, 35. And we can see it here. This is 1. This is also 1. So 7, 21, 35, 35, so 21, 7, and 1. So we got the same. So it's proven. Let us now use the formula. So we have the summation of 7 taken I times u raised to 7 minus I times v raised to I, where I starts from 0 to 7. And this will now be 7. We start from 7 taken 0. Now move to 7 taken 1. 7 taken 2. 7 taken 3. So we have 7 taken 4. 7 taken 5. 7 taken 6. And then we have 7 taken 7. And this u raised to 7 minus I. So habang pinapalitan natin ang I from 0, mapapansin natin na pwede na natin diretsuhin yan into u raised to 7 because 7 minus 0 is 7. This will be u raised to 6, u raised to 5, u raised to 4, u raised to 3, u raised to 2, u raised to 1, and u raised to 0 is simply 1. Next, we observe that this is v raised to I. So I starts from 0 and then it will end on 7. So kapag v raised to 0, that is simply 1, so we don't need to write. So that will be v raised to 1, v raised to 2, v raised to 3, v raised to 4, raised to 5, raised to 6, and this is v raised to 7. Again, there's no v raised to 0 written here because that is already equivalent to 1. There's no written u raised to 0 here because it is already understood to be 1. Okay, so we have addition here. So the next thing we need to do is to evaluate now each combination. Now get your calculator and then we evaluate. Now if we continue using the calculator, we are now ready for the evaluation of each combination here. Okay, so just find the key on your calculator. So we start from 7 taken 0 is simply 1. So check it out in your calculator. That is simply 1. So we may now write u raised to 7 plus 7 taken 1 is equal to 7. So you can check in your calculator. 7 taken 1 is simply equal to 7. So we now have plus 7 u raised to 6 v. Okay, and that will be immediately followed by the second to the last, and this will be 7 u v raised to 6, and also the last term, that will be v raised to 7. Next, 7 taken 2 at a time is equal to, okay, let's check in your calculator, that is equal to 21. So it means to say this will become plus 21 u raised to 5 v squared, and the third to the last will also follow. This is plus 21 u raised to 2 v raised to 5. Now if we evaluate the fourth term, 7 taken 3 at a time in your calculator, that is equal to 35. So immediately have here plus 35 u raised to 4 v cubed, and that will be followed by the fifth term also because they are symmetrical. So this will be plus 35 u raised to 3 v raised to 4. So this is already the expansion of u plus v to quantity raised to 7. On this next example, let us present the two ways. Okay, we may use the first way presented a while ago. So we start on the first term. We have a raised to 4. Next, we have a raised to 3, a raised to 2. This is a raised to 1 is simply a, and a raised to 0 is simply 1, so we don't need to write. Next, we have 2b, the quantity raised to 4. So we write it here, plus 2b quantity raised to 4. We have to enclose that. This will be 2b quantity raised to 3, 2b raised to 2, 2b raised to 1, and 2b quantity raised to 0 is simply 1, so we don't need to write. To check the sum of the exponents, 3 plus 1 is 4, so all 4. 2 plus 2 is 4, 3 plus 1 is 4, and 4. We move to the numerical coefficients. The numerical coefficient of the first term is simply 1. Now the second term, you just need to copy the exponent here, 4. This is 4. The second to the last will also follow, and that is 4. Now to get the numerical coefficient of the middle term, get the product of 4 and 3. 4, the numerical coefficients, and the exponent of the first term, that is 3. So 4 times 3 divided by 2 is simply 6. So this will be 6. Then we're done on the expansion. So the next thing we need to do here is to have to expand the 2 here. Okay, so we observe here, this is 2 raised to 2, 2 raised to 3, 2 raised to 4. So we need to expand all of them. So we now have a raised to 4 plus 4 times 2. So we need to complete now. We have to simplify everything. 4 times 2 is equal to 8. So we have 8a raised to 3b plus, this is a squared b squared but when we square 2 here, then that will be equal to 4. So 4 times 6 is equal to 24. So this is 24a squared b squared plus, so 4 times 2 raised to 3 is 2 raised to 3 is equal to 8. So 8 times 4 is 32. Yeah, 32a b cubed. And we have to 2 raised to 4 is equal to 16. So this is 16b raised to 4. So we're done on the expansion. Now we compare the solution on the rule, the formula that is provided, and let's see if we will get the same. So if we will going to use the formula the second way, then we now have, okay, we now have 4 taken 0, 4 taken 1, 4 taken 2, 4 taken 3, then we have 4 taken 4. Next, we're going to get the first term a and raise it to the exponent 4. So we have a raised to 4, a raised to 3, a raised to 2, so that's decreasing, a raised to 1, and a raised to 0 is simply 1, so we don't need to write. Next, we have 2b. So we can start on the last term, 2b quantity raised to 4, or we can start on the first term or the second term, because that will be 2b itself. So we can have here 2b raised to 1 quantity, 2b quantity raised to 2, 2b the quantity raised to 3, and here 2b quantity raised to 4. And the operation is addition, plus. I'm using red for emphasis. Okay, so add all of them. Next, we are going to evaluate the value of each combination. 4 taken 0 is simply 1, so this will be a raised to 4. 4 taken 1 at a time is equal to 4, so this will be plus 4a raised to 3 times 2b plus 4 taken 2 is equal to 6. So we have 6a squared, and 2 squared is 4, so this is 4b squared. 4 taken 3 is equal to 4, so we have 4. So there must be no addition here in this part. This will be 4a. 2 raised to 3 is 8, so 8b cubed. 4 taken 4 is simply 1. Okay, so in this place, addition, 4 taken 4 is simply 1, and 2 raised to 4 is equal to 16. So we have 16b raised to 4. And then we get to simplify everything. So this will be a raised to 4 plus 4 times 2. 4 times 2 here is 8. So 8a cubed b plus 4 times 6 is 24. 24a squared b squared plus 8. 8 times 4 is 32. So we have 32a b cubed plus 16b raised to 4. And let's check if we got the same versus the first way. So we start from the first term, a raised to 4, so we got the same. 8a cubed b, the same. 24a squared b squared is also the same. 32ab cubed and 32ab cubed the same, and 16b raised to 4. 16b raised to 4 is also the same. So we can have the expansion of a plus 2b either of these two ways. The ith term of the expansion. Okay, so if we're looking for the specific term of any expansion, we can have the formula, the combination of n taken I minus 1 times a raised to n minus I plus 1 times b raised to I minus 1. If you're going to get the sum of these, the exponents, n minus I plus 1 plus I minus 1, getting the sum of this is automatically equal to n. So that is the intention. If we're going to add the exponents of the two terms, the total must be the exponent of the expansion. Okay, so let's try the first example. Find the third term of the expansion x plus y, the quantity raised to 8. Here, n is equal to 8 and I is equal to 3. Okay, so if we're going to place that in the formula, that will become 8 taken 3 minus 1 because I is equal to 3. And this will be x raised to 8 minus where I is equal to 3 plus 1, and this will be y raised to 3 minus 1, which is equal to 8 taken 2 at a time. X raised to 8 minus 3 plus 1 is equal to 6, and y raised to 2. So if we're going to add the exponents 6 and 2, that will give us 8. Okay, so this is 8 taken 2. So our answer will now be, so our answer is now equal to 28x raised to 6 y raised to 2. We can also prove that in the expansion, if we start to expand x plus y raised to 8, we know that we can start from x raised to 8, then move to x raised to 7, this is x raised to 6. So we're looking for the third term. And if that is x raised to 6, this must be y raised to 2. For us to complete 6 plus 2 gives us 8. So this is y raised to 1, or simply y. The numerical coefficient of the second term is 8, just copy. And then to get the numerical coefficient of the third term, as suggested, you have to multiply 8 and 7. So 8 times 7, and then divided by 2 because that's the second term. So 8 and 2 are divisible by 2, so this is 4 times 7. The second term must be 28. So it's proven in the expansion versus the formula. They're just the same. So if we are going to get the sixth term of the expansion a plus 2, the quantity raised to 7, n is equal to 7, the exponent, and I is equal to 6. So we now have 7 total number of the exponent itself taken 6 minus 1 times a raised to 7 minus 6 plus 1, and this is 2 raised to 6 minus 1. So this is now equal to 7 taken 5 times a raised to 8 minus 6 is 2, and this is 2 raised to 5. So if you're going to evaluate 7, the combination of 7 taken 5 at a time, that is equal to 21. So this is 21 times a raised to 2 and 2 raised to 5 in your calculator, that is equal to 32. So combine like terms, we now simplify. 21 times 32 will give us 672. So the answer is 672a squared. We can actually form a shorter way of solving this. Now, if you try to notice, we have 8 taken 2 already, because third term means 3 minus 1 gives us 2. So immediately we can write this is x, just simply place x, and this is y. So if this is 2, you can copy it out immediately here. So this is also 2. And then since you're forming 8, so 8 minus 2, then this must be 6. So that 6 plus 2 gives you 8. So the answer here can be immediately found. So 8 taken 2 at a time combination, that is equal to 28. 28x raised to 6, 7 raised to 2. On the second example, that is the sixth term, so ibig sabihin I is equal to 6. So that is 7 taken 6 minus 1 on the formula is equal to 5. So this 5 here will be followed by the second term 2, so this is 2 raised to 5. And the first term a, so 7 minus 5, you need 2 here, so that so that 2 plus 5 is equal to 7. And then you can simply simplify that now. The combination of 7 taken 5 at a time is equal to 21. So 21a squared, and then 2 raised to 5 is equal to 32. Therefore, our answer is multiply 21 times 32 is equal to 672. The answer is 672a squared. So you can just get the same. So in this example, we're looking for the fifth term, and this is 15. So ibig sabihin, n is equal to 15 with I that is equal to 5. So this will be 15 taken 5 minus 1 is simply 4. So 15 taken 4 at a time. So dahil 4 yan, ibig sabihin yung square root of y na ito is immediately raised to 4. This is x. So 4, tanggalin ang 4 sa 15, then this must be 11. So that 11 plus 4 is equal to 15. So if we simplify 15 taken 4 at a time in the combination, that is equal to 1365. 1365x raised to 11. And square root of y, the quantity raised to 4, is equal to y squared. Okay, so pwede natin yan paghiwalayin into square root of y. Makikita natin yan, square root of y, square root of y times square root of y is also equal to the square root of y quantity raised to 4. And we can see that is equal to y squared. So this can be immediately written into y squared. So the answer is 1365 x raised to 11 y squared. Since n is equal to 7 here, so we expect 7 plus 1, 8 terms. Since that is 8, we have two middle terms, the fourth and the fifth. Therefore, I here is equal to 4 and I is equal to 5 with n that is equal to 7. So we start solving the fourth term. So this will now be 7 taken 4 minus 1. And since this is equal to 3, then immediately 3y quantity will now be raised to 3. And this is x raised to 4. And the reason because we need to complete 7. So 4 plus 3 is equal to 7. Now we can directly have the simplified answer. 7 taken 3 at a time is equal to 35. So this is 35 x raised to 4, and 3 raised to 3 is equal to 27. So we have 27y raised to 3. Now multiply 35 and 27. We have 35 times 27 is equal to 945 x raised to 4, y raised to 3. So that is the fourth term. The fifth term is equal to 7 taken 5 minus 1, x raised to 3, because this will now give us a 4 as the exponent of 3y. Okay, and when you add 3 and 4 will give you 7. 7 taken 4 is equal to 35, so times x raised to 3 times 3 raised to 4. 3 raised to 4 is equal to 81. 81 raised to 4. So 35 times 81 is now equal to 2,835. Therefore, we have the fourth term, that is 945x raised to 4y cubed, and the fifth term, that is 2,835x raised to 3y raised to 4.